Hello everyone. This is from section 8.1. I assigned a number of problems from this section, actually quite a few, numbers 12 through 29. Some of these should be somewhat familiar, and then others have a different twist to them. But let's start with number 12. We are given a velocity function here, and so when we integrate, we will be basically figuring out the displacement of the particle. And the displacement is the change in position. Now, if we know where it started at time 0 being 15, then as we integrate that area represents the displacement of the particle. So in this part here, when the particle's displacement between 0 and c, what we notice is this would be -4, so it's going in another direction, and then -24, it's also going in to the left in this case, and then here would be traveling to the right. So what is the particle's displacement between 0 and c? Well, -4, -24, plus 5. So the displacement would be -23. Now, its position, however, is if it was at 15 originally, then its position would be now at -8. And that's going to come into play here. Now, what is the total distance traveled? Total distance traveled, remember, is the absolute value. So that would be 4 plus 5 plus 24. So that would be a total distance of 33. Now, we're supposed to find the positions of the particle at A, B, and C. Now, if it starts off at 15, then by the time it gets to A, its position would be 11. And at B, then that would be at 16. And then at C, then it would be at -8. For 15, it says approximately where does the particle achieve its greatest possible acceleration? Now remember, when we're looking at a velocity graph, the acceleration is the slope of it. So if we're looking at the velocity function, then we want to find out where is the slope the steepest, and it's supposed to be positive here. And I think if you look at this, the slope is greatest here at A. So we would say at A. Now, where does it achieve its greatest possible positive acceleration from 0 to C? So now we're looking for the greatest slope, positive slope here along this curve. And when we get to C, looks like that's the steepest over here. So this would be at C in this case.